In this video, we'll be going over what it means for a solution to be dilute and what it means for a solution to be concentrated. We'll also cover how to calculate the concentration of a solution with a unit we normally use in chemistry, molarity. Okay, let's try to identify, out of these two beakers, which one would be a dilute solution and which one would be a concentrated solution. Let's define these two things first. A dilute solution is where there is not a lot of solute dissolved. A concentrated solution is a solution where there is a lot of solute dissolved. I'll give you 5 seconds to make a prediction. Were you thinking this? One way you could have gotten this is just by looking at which solution looked darker. Macroscopically, that is, with our eyes, concentrated solutions have a deeper color to it, while dilute solutions look lighter. We could have also looked at the microscopic view with the zoomed-in images of the particles in each solution. A concentrated solution should have more solute particles in any given part of the solution. One thing to note is that the volume of a solution does not tell you any information about whether a solution is concentrated or not. For example, even though there is more solution in beaker 2, that solution is dilute when compared to the solution in beaker 1. We need a unit that be able to tell us how concentrated a solution is. There are many units of concentration: molarity, molality, percent by mass, percent by volume, parts per million, parts per billion, and a few more. But for the purposes of this video, we'll go over the one that is normally used in solution chemistry. Yep, that's molarity. Molarity is represented with a symbol, capital M. You might have seen this in the lab setting. It is important to have almost all solutions labeled with their concentrations. In this photo, you can see the M symbol on each of these bottles: 0.8 molar potassium hydroxide, 0.08 molar potassium chromate, 1 molar potassium chromate. So, even though M represents molarity, we actually say molar when we read it. Now, molarity is calculated very simply. For any given solution, you just take the amount of solute that's in the solution in moles and divide it by the total volume of the solution in liters. I'll add this to the definition that you should try to remember. I want to go over a simple idea, which is illustrated really nicely in this PhET simulation. You can do the simulation yourself if you want. But if we had a beaker of water and we increased the amount of solute in it, what would happen to the molarity? Molarity would go up. That makes sense. Now, this is the maximum amount of solute I can add in this simulation. Here's a question. How can I make this solution even more concentrated? What else can I do? Oh my gosh, we could start with less water. If we start with less water and put the same amount of solute as before, the solution becomes even more concentrated. This leads us to a key idea. The concentration of a solution depends on both the moles of a solute and the liters of solution. Adding more solute to a solution will make it a higher concentration, but removing the solvent would also make the solution more concentrated. I want to show you one last thing relevant to solutions. This is just a reminder that all solutions have a limit or a threshold to how much solute can be dissolved. For example, in this amount of water, I'll start to slowly add copper sulfate. You should notice that it reaches a point where the copper sulfate appears as a solid on the bottom. That's because when the solution is saturated, the water can no longer dissolve any more of the substance. Okay, we're going to do just a few calculation examples. For this first example, what is the molar concentration of the solution described on the right? Now, on the right, we have a picture of a beaker which contains 10 grams of copper sulfate. And if you look at the volumetric graduation right there, it's about exactly 40 milliliters. Okay, so we have some information here. In order to figure out concentration, we should first write down the formula for concentration. Do you remember what it is? Molarity equals moles of our solute divided by the liters of the solution. So in order to solve for our concentration in molarity, we're going to need these two pieces of information. Do we have the moles of solute in this problem? And do we have the liters of solution in this problem? Well, I'll tell you how we can get those two numbers. So to get the moles of solute, you would actually have to do a simple conversion. All right, to get the moles of solute, we first start with the grams of our solute. Right? Because you have to remember, to get moles, if we have grams, you have to multiply by something called molar mass. So times and draw a line. The unit grams of copper sulfate should go on the bottom, and we're trying to convert to moles of that same solute, copper sulfate. This is a molar mass, meaning we're going to have to look at the periodic table, and we're going to have to find the molar mass of copper, sulfur, and oxygen. Just know that there's one copper here, there's one sulfur, but there is 4 oxygens. So add up all of those molar masses. What you should get is that there is exactly 159.62 grams of copper sulfate for every 1 mole of copper sulfate. Now, when you multiply these two, the unit that appears on the top and the bottom, that's exactly the same. They cancel out, and we're going to be left with moles of copper sulfate. So yeah, we actually can get moles of solute so that we can solve this problem. If you take 10 and divide it by 159.62, you should get about 1.575. If you take 10 and divide it by 159.62, you should get about 0.063 moles of our solute. Okay, now to get the liters of solution. How do we get that? For the liters of our solution, what we do know that we have, according to the beaker, about 40 milliliters of the solution. Okay, we need it in liters though. How do you get liters? You have to remember that for every 1 liter of a solution, or any liquid for that matter, there's 1,000 milliliters of it. Okay, for every 1 liter, there's 1,000 milliliters. So if we do a real quick conversion with milliliters on the bottom and liters on the top, what we should get is 40 milliliters is actually 0.04 liters. Okay, I'll show you a quicker way to do this if you like to take shortcuts. If we have 40 milliliters, to change it into liters, you just start with where the decimal is right now. It's right after the 40, and you move it to the left 3 times. You see how that is also 0.04 liters? So to turn milliliters to liters, you take a decimal and you move it to the left 3 times. If you want to do the opposite conversion, you just take the decimal and you move it to the right 3 times. Okay? All right. Now that we have both moles of solute and liters of solution, and we know the formula for molarity is moles of solute divided by liters of solution, we just divide those two numbers. So I'm going to go ahead and write it. Molarity is equal to 0.063 moles divided by 0.04 liters. Okay, And if we type this in a calculator, you just simply divide it. We should end up with 1.575. And the unit is moles per liter. Okay. The unit alternatively can be written as just simply M, because M represents moles per liter. It represents a unit of molarity. So either of these two can be the answers. In our second example, we have a solution that has a volume of 375 milliliters and contains 42.5 grams of sodium chloride. What's the molarity? Okay, to solve for this problem, we want to start with the formula. Molarity equals moles of solute divided by liters of solution. We are trying to solve for molarity. That's what the question is asking for. And that means we will need to figure out how many moles of solute there is and how many liters of solution there is. Okay, now according to the problem, we have grams of solute. That's not moles of solute, but we can easily turn it into moles with a molar mass. And according to the problem, we don't have liters of solution, but we do have milliliters of the solution. And to get milliliters to liters, you just simply move the decimal over to the left 3 times. Okay, so I'm going to go ahead and do those two things. So I'm going to start by figuring out how much moles of solute we have. We're going to start with 42.5 grams of our solute. And to turn from grams to moles, you multiply by molar mass. I'm going to write grams of NaCl on the bottom and moles of NaCl on the top, because that's what we want to convert to, moles. To get the molar mass, we're going to have to look at the periodic table. If you look at the periodic table, the molar mass of sodium is 22.99, and the molar mass of chlorine is 35.45. So to get the molar mass of NaCl, you just add the two together. Now, it turns out the molar mass of NaCl, if you add them together, it's going to be, let's see, it's going to be 58.44 grams for every 1 mole of NaCl. So you go ahead and cross out the unit that can cancel out here, which would be grams of NaCl, and we're left with moles of NaCl. So since that's what we want, we're going to go ahead and throw an equal sign. We need to do a division here. 42.5 divided by 58.44, and that's going to give us about 0.73 moles of NaCl. Okay, so we have moles of our solute. Good. We just need liters of our solution. So to get liters of the solution, we start with 375 milliliters. Okay, and I'm going to do the shortcut here. I know that 1 liter is 1,000 milliliters, and I can convert here. But the shortcut is to take the decimal and to move it back 3 times. So the liters is 0.375 liters. Okay, so 375 milliliters is the same thing as 0.375 liters. So now I just need to divide moles by liters to get the molarity, to get the concentration. So molarity is equal to 0.73 moles, and we divide it by 0.375 liters of our solution. So take a calculator, divide those two numbers. What we should get when we divide these two numbers is about 1.95 moles per liter. Okay, so that's the unit of concentration here. Alternatively, you can write the unit as capital M, which stands for molarity. So either of these units would work. Either of these answers would work. Okay, here's our last example. Calculate the molarity of a solution prepared by dissolving 392 grams of solid sodium hydroxide in enough water to make 3.62 liters of solution. So we want to find the molarity again. Molarity is equal to moles of solute divided by liters of solution. So we want to figure out molarity. That means we need to know moles of solute and liters of solution. For the moles of solute, we don't have it, but we do have grams of solute. We can convert that to moles of solute with molar mass. And for this problem, we do have liters of solution, so we don't have to do any conversion. We can just use that number when we do our division, right? So I do need to figure out moles of solute first. So we start with our grams of solute, and we multiply by molar mass to get the moles of solute. Okay, what's the molar mass of NaOH? Well, here are the molar mass of each individual element. We just need to add all of them up. There's only one Na, there's one O, and there's one H. So just simply add each one of them together. If you do add them together, you'd find that the molar mass of sodium hydroxide is approximately 40 grams for every 1 mole of sodium hydroxide. Now I'm going to go ahead and cross out the unit that can cross out here, grams of sodium hydroxide. We're left with moles of sodium hydroxide, and that's what we want. So I'm going to go ahead and throw in our equal sign. We're going to do a division here. 392 divided by 40. 392 divided by 40 in the calculator should give us about 9.8. And the unit is moles of sodium hydroxide. Okay, now that we have moles of sodium hydroxide, and now that we have liters, we can go ahead and divide the two to get molarity. Molarity is equal to, our moles is 9.8 moles. Our liters, it's in the problem, remember, is 3.62 liters. We don't have to do a conversion here. It's already in liters. So we just go ahead and type this in the calculator. 9.8 divided by 3.62. Now this number is going to be 2.71. The unit, since it can't cross out, is moles per liter. The unit moles per liter can alternatively be written as molar with a capital M. Okay, so I'm going to go ahead and circle both of these because either way you write it, would be correct. All right, I'm going to go ahead and give you one practice problem now. For this practice problem, I want you to try it on your own first, and then I'm going to give you the final answer. Okay, so pause the video because I'm going to give you the answer in like 5 seconds. And that's the final answer. So if you didn't quite get it, you can ask me for help, but you can also take a look at the video examples again and see if you kind of get the idea before you ask me for help. Okay, I'm going to have just a little bit more practice for you, and I want you to go ahead and try those practice problems, and I'll give you feedback if you'd like for those problems.